In this video, we will see how to derive the equations of motion. So, we are going to use the velocity time graph for deriving the equations of motion. So, we have got a velocity time graph here. The velocity of this object for which the graph is plotted is starting from non-zero initial velocity. And that's the reason we can see that the velocity time graph is not starting from origin, but it's starting from some point on the y-axis. Now let's just label the graph with the final velocity, initial velocity, and the time interval. We know that the velocity time graph slope gives us acceleration. So acceleration is equal to the slope, which we know from mathematics is y2 minus y1 over x2 minus x1. And on the y-axis we have velocity, so we will have vf and vi. So vf minus vi over delta t, that will be the slope of the graph. Now this we can rearrange by taking delta t on the other side, and we get a delta t equal to vf minus vi, which we can further arrange to get vi plus a delta t equal to vf. And to make it in a proper form, we can write vf equal to vi plus a delta t. That's our first equation of motion. Now we will check the second and the third equation of motion, the derivation from velocity time graph. So again we have taken the same velocity time graph. We know that the displacement from a velocity time graph is found by the area under Vt graph. And that's this shaded area which we see in the graph. This shaded part can be divided into two parts, one triangle and one rectangle. So the displacement delta x will be equal to area of triangle plus area of rectangle. From mathematics again, we know that area of triangle is half base into height and area of rectangle is length into width. So let's check what is the base of the triangle. It is delta t, and the height of the triangle is vf minus vi. Be very careful, the height of the triangle is not vf, but it is vf minus vi. So we substitute that into our equation to get the area of triangle. Now for area of rectangle, we can see that the length of rectangle is delta t and the width of rectangle is vi. So we can substitute that, and our equation becomes delta x equal to vi delta t. We have just rearranged it to bring it in front, plus half delta t vf minus vi. Now vf minus vi divided by t is actually acceleration. So we can write a delta t is equal to vf minus vi, which we are going to substitute in the equation of displacement which we got before. So in place of vf minus vi, we will substitute it by a delta t, and then we'll simplify this equation to combine delta t together. It becomes delta t square. And we said that delta t can also be replaced just by t. So our equation becomes delta x equal to vi t plus half at square. That is our second equation of motion. Let's look at the third equation of motion, how to derive it. Again, we take the same graph and we apply the same concept that displacement is area under Vt graph, which is the area of the shaded part. Now this time we will not divide into triangle and rectangle. Rather, we will identify it as a trapezium because it has two parallel sides and two non-parallel sides. Area of trapezium from mathematics, we know that it is half the sum of parallel sides multiplied the distance between the parallel sides. So the sum of parallel sides, you can see the yellow highlighted lines are the parallel sides. So we want to get those parallel sides, which is vi and vf. So half vi plus vf, and the distance between the parallel sides, we can see that it's delta t. So we replace that by delta t. Now this delta t, we know it is related to acceleration by the equation acceleration equal to vf minus vi over delta t, which we can rearrange to get delta t equal to Vf minus Vi over A. We are going to replace this in place of delta t. And now we have got half Vi plus Vf multiplied by Vf minus Vi over A. We are just going to rearrange it and use some mathematical tools to get the final equation. We can see that here I have just rearranged it and written Vf plus Vi multiplied by Vf minus Vi over A. The reason for making it in this form is that now we can apply the identity from mathematics, which is A plus B into A minus B, which is A square minus B square. So here it will become Vf square minus Vi square, because it is Vf plus Vi multiplied by Vf minus Vi. Now we just rearrange it, take delta x and 2a together and get Vf square minus Vi square equal to 2a delta x. We can take Vi on the other side and we get the third equation of motion, which is Vf square equal to Vi square plus 2a delta x.